Welcome back. In this session, we're going to be looking at modeling with curves and surfaces. So far we've been working in polygons, and so polygons are the primitives we've got. Obviously, we've got sphere, cube, cylinder, etc. And we've had a play with modeling with those, but there's another side to primitives, which is curves and surfaces. So we're going to look at how these are used. We'll very briefly talk about why they used to be used and kind of what they used to offer. But even though they're generally obsolete as primitives, you can still argue that there's so many uses that you can use them for now because of the tools that were created to facilitate them. So what am I talking about? Well, if we have a look at some of the primitives here, so we've got a NURBs cube here, so that's what we call a primitive that's created using these kind of curves and surfaces methods. So if we bring a cube, a NURBs cube in, and we bring a polygon cube in, so the interesting thing then, so if we look at our polygon cube, so we've got this here, and we can select our vertices on a cube, and if we select this and decide we want to move it, so we'll move this up and over, you see how what's actually happened here is that we've created a point, or if we were to say select a face and try and move this, you see how it skews the whole thing, and it's kind of connected in a way that means it's going to shift everything else that it's connected to, as you'd kind of expect it to. Yeah, well, this is a really interesting thing when it comes to NURBs. So NURBs are created with single planes all stuck together. So instead of them being a singular model that you can move around and it will push and pull around as you'd expect, if we move this, you'll actually see that what we have here is just a box. So each of these planes just falls apart and it comes off. So you can probably already see that it can be quite hard to imagine how you go about modifying these and modeling with them. You can also probably wonder, well, why would I ever want a cube in this form? And the truth of it is, you probably don't really ever want a cube that's a NURB, because it doesn't really offer you much. Where a NURB works is if it's a curved surface. So as a very quick history lesson, NURBs were designed as a mathematical way to be able to show something as rounded without a huge amount of CPU resource. So let's destroy all these objects, and let's take a sphere. So if we look at a polygon sphere and we look at a NURB sphere, so we'll move those over like this. So we have our polygon sphere here, and what I'm going to do is I'm going to change on our inputs, I'm going to change this to what have we got here? So that looks as inputs we've got sections is 8, so we'll do the same on here so we can kind of compare the two. So subdivisions here, we'll do this to type 8, and we'll do this to 8. It wasn't 8 on that side, was it? Let's have a look. Spans was 4, so we'll do it to 8 and to 4. So what I'm trying to do here is just trying to give you an example of what a NURBs can do versus what a polygon can do. So with the same amount of geometry, the same amount of control surfaces for the computer to think about, this is what a polygon will look like if we try and make a sphere with 8 sections going around the center and 4 sections going around from top to bottom. And this is what a NURBs will look like with 8 going round the center, and 4 going top to bottom. So one looks round and one looks very sharp. So what's actually happening here? Well, basically, NURBs were created as a way to mathematically show something that follows a curve, and it was done in a way that this sphere is made up of one single sheet that is then wrapped around itself. Let me show you that as an image. So if I go into my desktop, I've got an example here. So each of these fairly complex shapes, so this shape here, this cone shape, this kind of squished ball, all of these are created with a singular sheet in some way. So you can see the red edges, and this is where they'll meet, and it's a stretching of these sheets that allows them to create these shapes, and obviously a slightly different shape, which then allows you to create a curve, like a cone shape, and then stretching on both sides to allow something that's spherical. So they actually require very, very little computing power in order to create them. And in the days, if you look, 15, 20, 25 years ago, in the infancy of 3D animation, and obviously other types of 3D, in the infancy of all of that, it was very hard to show anything as being perfectly smooth. So you can see that actually, before we turn on smoothing, if we want to get this polygon sphere to look anything like this, we will actually need to bump this up to, let's say, subdivisions of 32 to 32. Let's say that. To my eyes, that looks nice and smooth. We might be able to knock that down to, let's say, 24 and 24. Yeah, and that'll do it. But basically, we're going to need quite a lot of these subdivisions in order to make it look nice and smooth, whereas this won't. So if you weren't going to do any kind of smoothing on the object, then obviously this is the way to go. And when you bear in mind that 15, 20, 25 years ago, technology at the time, whether that's consumer technology or even professional technology, just fundamentally couldn't do this without having a serious performance issue. This was why NURBs were used. But NURBs have tools that are still relevant today, even though we can now do this quite easily on pretty much any kind of device you'll come into contact with. So the reason why we're going to be looking at them today is because we're going to be making stuff using the tools that are designed for creating NURBs objects. So all NURBs kind of start out using a curve. So we have tools that we can use to create those, and we're going to play around with one in particular. And so that's this one. So that's the CV curve. And the way we're going to find that, I've added it to the shelf, but I'll show you how to find it on yours. But if I go into my front view, I'm going to be able to draw on this using the curve, and then we're going to be able to use it to create some forms from it. And they're going to be fairly complex forms, and it's going to be quite a quick process. So what I'm going to do is I'm going to go to Create, and then you see we have Curve Tools, and then we have CV Curve Tool. Now, I'm not just going to click this, I'm going to click into the options for it to see what we're doing. So the first thing it's asking me, well, what is the curve degree? We've got 1, which is linear, which means it's going to try and curve every single point that we create. We have 3, which is cubic, which means it's going to try and curve based on each 3 points that we create, and then 5, obviously, as that goes up. The knot spacing, which is kind of where when it automatically puts the kind of the handles that create the curves, how it does that, whether it's doing it in a uniform way. But that's basically just what we want to know is which type of curve degree are we using, and we're going to use 1. So we can go into here then, and then go into Curve Tools, and then CV Curve, and now we have our curve tool ready to go. So we're going to do something that's almost like a rite of passage when it comes to 3D modeling, and that's to model a wine glass using a curve tool. It's one of the first things that you'll see on probably most 3D courses. And we're going to start by creating curves on the front view. So the first things first. Generally, when you start and end a curve, you want it to be at the absolute perfect origin point, so that you don't end up with slightly overlapping or underlapping meshes. And it's really easy to do if we can snap to the grid. So up the top here, we've got some magnets with different options. We have snap to the grid, we have snap to curves, we have snap to points, and some others, but we're going to be using snap to grid to start with. So I'm going to turn on snap to grid, so I can just click that, and it means that anything I place down is going to snap to the grid. It's going to snap it to its closest point that it could be. So if I were to click like here, for example, it's going to automatically put that point over there for me. And so what I'm going to do is I'm going to kind of imagine drawing the shape of a wine glass. Now we could get reference for this. We could, get a picture from the internet. We can go to view, image plane, import it in, set the midpoint of the stem of the glass, going up, and then we can follow that as a glass. But I actually think it's, especially good with uni students to see who can model a wine glass from memory based on how much wine you drink. So we'll give it a go. So what we're going to do then is we're going to click another point here. So it's going to be completely flat at this point. And then we're going to want to have full control. So I'm going to now turn off snapping to grid. And I can then come out to here, add a point, and I'm just clicking singular points. It will curve them for me as we kind of go around. And we'll start to create our imaginary wine glass. Now, generally speaking, you want to keep as few amount of points as possible, so that you don't end up with a massively over-engineered curve. So stuff where you have straight lines, you really don't need to put too much in there at all. So we'll just have kind of one that goes between here and there. We'll then start to curve this out for the kind of the bell of the wine glass. And then we'll start to curve this round in here. And so a good rule of thumb is to, we're going to put a little bit there so that, the wine glass isn't perfectly straight. It's going to kind of have a slight lip to it. And we want to kind of simulate that there is thickness to this glass, because glass isn't perfectly thin. It's got a thickness to it. But a rule of thumb is it's a good idea to keep the vertices that we're adding in on the other side roughly in line with where the other ones are, just because it's helpful to keep track of where each edge loop actually ends up being. Misclicked, and then we're going to start to kind of get wider here. So there we go. And then I'm going to turn snapping back on. And I'm going to snap to the grid there. And I'm going to move into my selection tool. I will go into control vertex. I'm going to select this last one. And I know that it's perfectly within my origin point. But what I want to do is I want to move it up. I need to turn off snapping. I want to now move it up in the y-axis, because I know that I don't need to move it in the x-axis in any way, but I can then move this up and just get this to where I kind of feel it'll be right. So if we now zoom out, we can kind of look there. It looks like an okay wine glass. It probably could have done with a slightly different bowl here, but it's not the end of the world. If we wanted to change it, we can still just go in and change whatever we want. So we can select this vertices here, and then select this one, and then select this one. In fact, as we're doing it, I may as well make it nice and neat now. Something like that will work. But as we can see, it should kind of work. It's maybe a little bit of a wide wine glass, but it's not the end of the world. So what we now have then is a curve. So if I go into object mode, we can see that, and it will highlight that as the object. So we can use this curve to create geometry, and so we would normally, you'd use the curve to create a NURBs, but we're actually going to use this curve to create some polygon geometry. So the way that we can go about doing that, with our curve that we've created selected, we can go into our surfaces menu at the top, and then we have a create section, and we can create using different types of processes. So we're going to look at loft a little bit later, but for right now we're going to look at revolve. So I'm going to click the options for this so we can see what's happening when we do it. So the revolve almost creates something like a lathe. So if you've ever seen somebody like create a wooden spindle or something that is kind of formed as it's spinning around, and you use a blade to kind of carve it out, it's going to do a similar type of thing, where effectively we're going to be rotating this shape around its y-axis. If you imagine it's spinning in the up and down axis here, so it's spinning round and round and round and round, and that's what's going to create our geometry. So the axis preset, we've got it set to Y. We're going to pivot around the object that we're creating, so it's effectively going to make the pivot point in the center of where the object gets created. We've then got our surface degree and how this does it. The main part that we need to look at is what is the sweep angle. So if we start from 0 and we go to 360, it's going to create, it's going to do an absolute full circle, which means that we're going to have a joined up finished piece. And then we also have the segments. So this is kind of like our subdivisions. And because we're going to smooth this, 8 should be more than fine, so we'll keep it at 8. We then have whether we want to output the geometry to NURBs or if we want to output the geometry to polygons. I'm going to say polygons because it's going to be more useful to us in a general sense when we're using it in things like in game engines or in our animation, whatever we're doing. Generally speaking, we're going to be using polygons, but it's nice that we have the option there if you ever wanted to create it as a NURBs. And then it's going to ask you about the tessellation method. So this is how it actually creates it and how it creates the edge loops and the vertices and basically all of the geometry we can edit. So we can have it in general where it kind of runs an algorithm to do that. But actually, if we do it as control points, each one of the control points that we created is where it's going to create the edge loops that we can control it from. And based on us putting fairly sensible control points in place, as I said, keeping them so they're lined up on the inside to the outside, it's probably a good point to use the control point. So what we'll do is we'll click revolve, and you'll see that that has now in the front view it just looks like it's just doubled it over and turned it black. But if we go into our perspective view, you can see that we now have a wine glass shape. It's black, and it's not black because it's a kind of Halloween type novelty cup. It's black because the program doesn't know what the inside and outside is, or rather it's in disagreement with me what it thinks the inside and outside is. See, I think the outside is this section, and even the inside of the actual cup is still the exterior part. The interior of the model is actually on the other side of, it's inside the actual glass structure. And that's because just Maya, the way it's built it, it thinks that we've got it wrong. It's very easy to fix. We can literally just go to, where will we find it? It's going to be in mesh display, and we will then find reverse. And that's just going to reverse the mesh. So the normals, which is what we call the kind of skin that a model gets, we can have it around the right way or we can reverse it. And there's plenty of reasons why you might need to do this at some point. So I'm just going to click that, and then it's reversed it. So then we now have our model. So obviously this is before smoothing, which is all good. But what I'm going to do is I'm going to show you something fairly interesting. So if I select and move this model, you can see we've still got our curve. Now, in Maya, your models, anything you create has a history to it. So when you click, undo a load of times, you've got history in, what you're doing to the thing, but it actually also has history based on this stuff. So that's the inputs. So this piece of geometry has inputs that come from other stuff, and that other stuff is the curve that we created. So what that actually means is that if we were to now come into this curve and right click and select control vertex, let's say that we wanted to change the base of it. Maybe I think the base is too thick. So let's say that we wanted to select this section here and move that. Well, if we select the move tool on here and we now move this up and down, you see we're actually controlling the final geometry that we've created, because we're still connected to it effectively. It's still being created based on our history. So it's just something interesting to know. Ideally, you want to, at some point when you've got a model basically done, you want that history to be destroyed so that you don't have too much history in a scene. Too much history in a scene can eventually just lead to things where you don't know why something isn't working, and one thing that you move is destroying another thing. So just bear in mind that it's something that you usually will need to get rid of history between objects at some point. It's really simple to do. You just select the object you want to remove the history on. We can go to edit and then delete by type, and then we have history. And you actually see we have non-deformer history. So if we wanted to keep this link but delete the rest of the history, we could actually just do that. But if we just hit delete history, it will then mean that if we then made changes to this, so let's pick something else. Let's pick this edge here. Let's say that we wanted to now move this. It's now not going to affect our geometry. So that's just in a nutshell what the history is all about. So here's our model then. So let's look at smoothing it and let's see what it looks like once I hit 3. There we go. So that would be our wine glass, and probably not the worst wine glass, but also something that takes just a couple of minutes to do. So very quickly then, I said that we were going to look at using the loft function as well, because if we go into our surfaces, we had revolve and we had loft, we have planar. We won't look at planar today, but we'll very quickly look at loft and see what you could do with it. So I'm just going to delete the wine. Actually, we'll just move it out of the way for right now. So what I'm going to do then is I'm going to start by drawing another curve onto here, and I'm going to select my CV curve, and I'm going to start drawing a shape. So let's start at the bottom here, and in fact we'll turn on snap to grid so that we actually end up in the origin point. It's generally just a good thing to have happen when we're doing something like this. And I'm going to, in fact I'm going to keep snapping to grid, because it's probably just going to make life a lot easier. So what I'm going to do is I'm going to make a kind of a circular shape, but something that's a kind of squished circular shape. Basically something that's a little bit complex, something that you wouldn't necessarily just find a primitive for. And this could be anything. This could be an engine, an engine nacelle that you get on like a jet plane. It could be part of a spaceship. It could be literally whatever you want it to be. And then I'm going to turn off our snapping here. I'll show you the reason why. I basically want this point here to eventually pin itself to the origin point, but I have to do it in a bit of an awkward way. Basically, I turn off the snapping, and then that's going to allow me to hit the control vertex here, select this one, and then I'm going to turn on snap to, what's this one here? So snap to points, this one. And then when I move this, it's going to snap me to my nearest point. so that hopefully we should end up perfectly aligned. Let's have a look. It's not doing what I wanted it to do. Let's do snap to grid then. If it's, there we go, we'll snap it to grid. So this is giving me a shape. Now with this shape I'm going to be able to play with it in 3D space, which is obviously useful. So what I'm going to do is I'm going to come out into my perspective view so you can see our 3D shape here. And then what I could do is I could select it. I could then Command D to duplicate it and then move it. I'm just going to turn off snapping to the grid because I don't want it to do that anymore. So let's roughly move it 2 spaces out. And then I can deform it. So I might want to actually like scale it slightly up this way and slightly out this way. And then we'll duplicate again and we'll move back to roughly 2 places out again. And maybe with this one we will scale it out sideways again a bit more. And then if we duplicate again and move it back, and then maybe we push this one back by 3. And we can then start to scale it back down again. And effectively what I'm trying to do, I'm kind of imagining that I'm making a like a kind of sci-fi type spaceship fuselage that kind of feels like it's part of a living organism. So it's kind of it's almost like an organic curve, but it's almost like part machinery, something that's kind of complex that you wouldn't just have a decent primitive for. So and it's also kind of good to imagine this as almost like vertebrae on someone's backbone. That's kind of, it will eventually all be formed together to create a shape. So we will duplicate again. We'll then move this one back and we will scale this one down further, and we'll probably move that one up so that it seems to kind of follow a line. And I think we'll use that one again to create a bit of a front section. And I think that's going to kind of do what we want to do. So let's just have a look at what we've kind of made. So this could be used for all sorts of things, but effectively what we're doing is we're kind of outlining a rough shape. Now all of these were created using the exact same shape that we started with, but there's no reason why you couldn't actually make multiple versions. You know, if you had 5 or 6 of them that change as the shape kind of goes back, there's no reason why we couldn't link these all together. The point is what we're going to be able to do is we're going to be able to select these and turn these into geometry based on the control vertices that we've created. So let's have a look at how we do that. So what you'll need to do is you'll need to select them, and you select them in the order that you want them built. So we could either select them from the front here and then go backwards like this. So I'm holding down Shift, and so I'm selecting them in the order that they go at. If we were to select one and then come back here and select this one and then here and here, it's really going to confuse the system and it's not going to turn out right. By doing it this way that I've done it, you'll remember that when we made the wine glass, it was initially inside out and we had to change it. In theory, if I do it from the back, it's actually going to work how I want it to without having to change it. So we're just going to give that a go. So I've selected from the back, hold down Shift, and then click each one until I get to the front. So now I'm going to go into my surfaces and I'm going to select Loft, but I'm going to use the options button, and I'm going to have a look at how it's going to do it. So first of all, we've got uniform, we've got the section spans. So the section spans is how many lines is it going to create in between each of these sections. And I actually probably don't need it to do anything in terms of that. It's probably fine as it is. So I'm just going to keep that on 1. The point is that it's a bit of trial and error. You have a look, see how it generates the geometry and then maybe undo it and then make a slight change. So then we also then have the curve range, complete the output geometry. We're going to go to polygons again, and then it's how are we actually going to do it. So I think again we'll work with the control points, because the control points seem to give us enough to outline that shape. And then if we hit loft, that's going to create us a piece of geometry. So again, it's a fairly quick way to make something that's quite complex, but also by doing it this way, if I now move this piece of geometry, let's say that these sections here at the top that cause almost like a fin, let's say that we wanted to tweak those as we kind of go through. We could quite easily select them as a control vertex on each one, and we can make changes as we want. So again, it's quite an interesting way of being able to control an object. Obviously we can smooth it and we can kind of see what we end up with. But it's an interesting way to work. It's something that if you're trying to flesh something out that needs to make sense for a biological or a mechanical reason, that it seems like it's almost either machined or it's been grown by an organism, it's kind of a good way to work, because it tends to be the way that these processes actually work in the real world. But that's the curve tools. That's kind of making geometry using curves, and we will move on to some other modeling techniques in the next sessions. Thank you very much.